ExaM, Unsupervised Concept-Based Representation Learning to Better Explain Models and Vision Tasks. The motivation for this paper was to make interpretable by design models that scales to multiple computer vision tasks and architectures and maintains performance of the equivalent standard backbone or architecture. The prior works on which this is based is object-centric representation learning, on which we adapted to a task of self-supervised concept representation learning. Our approach essentially adds a interpretable branch to an existing model on which this branch is connected to the image feature map and shares that map with the task branch. And that interpretable branch outputs a concept activation map and then a concept activation vector, which defines the detection of certain concepts in an image. The concept representation learning is done through a soft concept assignment using a softmax function between learned concept representation and the actual feature map. The self-supervised constraints used to achieve this task is based on a concept alignment loss, where geometric transform on the input image should lead to the same geometric transform on the concepts themselves. To avoid learning trivial shortcuts, other losses are added, such as preventing learning on mask areas. The results we achieved, essentially, it leads to almost no complexity cost over the baseline model. It shows a significant improvements when comparing explainability metrics such as stability, sparseness, and faithfulness of the obtained concepts when compared to the current state of the art. We also recover the baseline performance of the original model, and we achieve disentangled concepts. As an example, in a re-ID task, we have some concepts that were activated for a specific individual. In that case, we see that there's a concept for green clothes if we compare with the other images in the test set, and that is separated from the concept of a skirt. So the color here is disentangled from the clothes itself.